Hi everyone, welcome to Unit 6. This unit is going to be talking about linear graphs, functions, tables, and relationships. All the lessons in it we're going to be talking about lines and what kinds of relationships lines have. So the first lesson we have to talk about is proportional relationships. So your aim today is that I can determine if a linear relationship is proportional and use its properties to make a graph, make a table, and analyze questions. You've studied proportional relationships in previous courses in 8th grade, 7th grade, but they are the basis of all linear functions. Always remember that when you see the word linear, you're thinking of a line, right? The word linear has the word line in it, so we're thinking of lines. So we're going to use this lesson to recall more particular parts of proportions. So in this big box is the definition of proportion. Two variables have a proportional relationship if their respective values are always in the same ratio. They have the same size relative to the other. In equation form, if two variables are x and y, then y over x equals some number. Okay? I think the best way to show this is to use an example like usual. So let's take a look at exercise 1. And I think you're going to remember this kind of problem probably from 8th grade. So exercise 1 says at a local farm stand, 6 apples can be bought for $4. So I have 6 apples can be bought for $4. Determine how much it would cost to buy the following amounts of apples, round to the nearest tenth when necessary. So we're going to set up a proportion. Okay, so set up a proportion. Okay, so my first proportion, let me get my right pen, is a dozen apples. Now I have to think about how many a dozen is. A dozen means 12. So a dozen is a fancy word for 12. And my original proportion in this problem that it gives me is that it says 6 apples for $4. So I know that I have 6 apples for $4. So when I do letter A, I'm going to use that proportion to help me figure out the cost of a dozen. So I'm going to have 6 apples cost me $4. That has to be the same thing as 12 apples costing some unknown cost. I don't know how many apples, how much it costs to get 12, so I'm going to make that x. And now we're going to remember something from 8th grade, 7th grade called cross multiplying. When you have two fractions equal to each other, you can cross multiply. So we multiply these two things. I'm going to use a different colored pen here. So I'm going to multiply these two to get 12 times 4, and that's going to equal what happens when I cross multiply the other two things, these two things. 6 times x. And now I'm just going to solve. What is 12 times 4? 12 times 4 is 48. 6 times x is just 6x. And to get x by itself, I have to divide both sides by 6. And I get that the cost of a dozen apples is going to be $8. So 12 apples cost me $8. So proportion can really help you solve these real-life problems. Let's try letter B. Okay, now I want 20 apples. I'm still going to start off with my original 6 apples per $4, but now instead of finding a dozen, I'm trying to find the cost of 20. And I don't know the cost of this. Let's use a different variable, y. Actually, let me use the same variable, x here, just so we stay consistent. Cost. And I'm going to cross multiply like before. So I'm going to cross multiply these two. So I get 20 times 4 equals 6 times x. I'm cross multiplying. And I'll just simplify and solve like I did for the last problem. 20 times 4 is 80. 6 times, oh, yes, that's correct. 6 times x is 6x, and I'm going to have to divide both sides by 6. Now, in this case, when I put this into my calculator, because this doesn't come out evenly, I get that x equals 13.33, And that's what the problem is telling me to do, is to round to the nearest cent. So it says nearest cent, so I've done that. $13.33 is my cost for 20 apples. Okay? Let's take a look at letter C. If C is the total cost of apples and N is the number of apples bought, write a proportional relationship between C and N. Then solve this equation for C. So this is tricky, the way it's worded, but it's basically asking you to, hey, start off with your 6 apples per $4 like usual. But now, instead of setting it equal to something you know, like I know I want to buy a dozen or 20, we want to know, well, what happens if I want to buy any number of apples? So they're saying that let C be cost. So if I look at my proportion, cost is down here on the bottom, right? So see how the $4 lines up with cost? So instead of saying cost, I'm going to put C. And see how I have apples on top? Because there's 6 apples. I'm not going to write apples. I'm going to put down N because that's what the definition tells me. N is apples and C is cost. Now I've set up this relationship, and just like before where I cross multiplied, I'm going to do the same thing again. Except I've just got letters now instead of numbers. 4 times N is going to equal 6 times C. I'm cross multiplying. And now I'm going to simplify. 4 times N is 4N, and 6 times C is 6C. This doesn't really help me. 4N equals 6C. I've got 2 variables. What does the problem tell me to do? Solve this equation for C. Remember lesson, I think 2.5, where we had to solve for variables? Well, this wants you to solve for C, so I'm going to get C by itself by dividing both sides by 6. When I do this, I end up getting C equals 4 over 6N, but when I put 4 over 6 in my calculator or remember how to reduce fractions, I end up getting 2 over 3N as my equation. What this equation says is, in a very fancy way, it says that the cost of the apples you buy, the cost is going to be 2/3 times the number of apples that you purchase. Is what that means. 2/3 times the number of apples. Alright? Letter D says, graph this relationship below. So, I'm going to come to my data here, and I've got a few things that I need to do here. In order to graph this, I'm going to have to make a table, because I don't really know all of these. Oh, I shouldn't use X and Y. What should I use? I should be using C and N. So, let's try this again. So I've got N for my apples and C. So at 0 apples, it's not going to cost me anything, right? I don't buy anything at the place, it's not going to cost me anything. Let's skip to number 6. I know that this one works out pretty evenly. If I buy 6 apples, I can solve this. Let me give myself some more room here. Sorry. If I use this, if I want to try N equals 6, I'm going to have to actually plug in this to get N equals 6. So the cost is going to be 12 over 3, so it's going to equal 4. So when I buy 6 apples, it's going to cost me $4. So I'm going to go to my graph, find 6, and go up 4 to get the point 6,4. Now let's try N equals 12. Well, I already know what N equals 12 is. If I scroll up here, how much did 12 apples cost? Cost 8. So when I buy 12, I have to pay $8, which is, which is this point right here. And then the other point, I'm going to keep going here. If I buy 18 apples, notice this pattern going up. See, it goes 0, 4, 8. What do you think the next number is going to be? It's going up by 4 every time, so it makes sense this number would be 12. And we can check that by trying N equals 18. If we plug it in, C equals 2, sorry, my pen did a weird thing. C equals 2/3 times 18. That's going to be 18 times 2 is 36 divided by 3. That's going to equal 12. So it works out. Okay? And then I'm going to plot that point. So at 18, I get 12. And my graph looks something like this, like a line, right? So now, if I go to letter E, according to the graph, C of 15 equals 10. Illustrate this on your graph. Okay, so I'm going to go over to here. Remember, C of 15 equals 10. This is like my x value, and this is like my y. So this is saying the point, comma, 15, 10. I'm going to go over to my graph, find 15, 10. Right there is C of 15 equals 10. If I can get my pen to cooperate again, because it's not. Equals 10. That's this point right there. Oh, for crying out loud. Did anyone just see that? Okay, let's try that again. Make it blue. There we go. C of 15 at 10. So there's the point. And now this question is tricky, because this next question says, how do you interpret C of 15 in terms of apples and money? Whenever a question in Common Core is asking you to interpret, they want you to write some sort of sentence in English explaining what these numbers mean, right? If I just say, oh, C of 15 equals 10, that doesn't mean anything about the apples and the cost. That doesn't tell anyone anything. But if I say, oh, if I buy, remember, what does X stand for? X stands for apples, and the Y here stands for cost. That's like saying, if I buy 15 apples, it will cost me 11, oh, not 11, sorry. It will cost me 10 bucks. That's what that is, the interpretation. You're interpreting the numbers in English. If I buy 15 apples, it's going to cost me $10, right? What if I found another point on this graph? Let's say at, anywhere along here, if I pick a point, that's going to tell me the apples and how much it's going to cost. That's why graphs are very helpful, because you can just look at the picture and see your cost and whatever else you need to find. All right? Okay, let's go ahead and try the next exercise, exercise 2. If Jenny can run 5 meters in 2 seconds, and that's important, so I'm going to underline that. 5 meters, that's our original rate. So 5 meters in 2 seconds. Then which of the following gives the distance she can run over a span of t seconds, going at the same constant rate? So we're talking about proportion. So a constant rate means that x over y we talked about, right? So I'm going back here. See how we say, we can set up a proportion. If it's a constant rate, it's going to be the one variable over the other variable. So one of my variables is meters and the other is seconds. So I can start to create a proportion to figure out this problem. So my first thing I'm going to write is that I know that my first proportion is 5 meters over 2 seconds. I know that, and this question is saying, give me something more general that I could find, D and T no matter what. So if they're telling me that distance here, D, that's meters, distance, and seconds is, obviously the time here. So I can write that meters stands for D, because that's what's on top, and on bottom is T, because that stands for time. Okay? Now this is helpful because now I can cross multiply like I did before. I'm going to multiply that 5 times the t to get 5 times t, and I'm going to multiply the 2 times the d to get 2d. So I'm just creating this proportion and then create an equation from it. And now I can solve this equation. I can say now 5t equals 2d. I'm going to go back up to my problem because this question is saying which of the following gives the distance. So this is saying solve for d. In a very weird way, it's saying solve for d. Most of the trouble comes from us not understanding the problem when it's saying, right? So in this problem, they only give us a 5, a 2, a d, and a t, and you've got to figure out how to put it all together. So it's really, really important to read carefully to figure out what this is saying. This is saying solve for d. Let me write this a little nicer. Solve for d. So to solve for d, I need to get d by itself, so I'm going to divide both sides by 2. The 2's cancel out, and I get d equals 5 over 2t. And is that an answer choice? Absolutely. It's answer choice number 4. Okay. Exercise 2 illustrates one of the most important proportional relationship, that of distance traveled compared to time. Distance over time, this right here, if I've got distance over time, this is one of the most important relationships we work with in math. And distance over time is something we talk about a lot, which is speed, right? So if she's running, she's going a certain speed, 5 meters in 2 seconds. Now, you're used to hearing things like 60 miles an hour and 100 miles an hour, but we've got to realize that really, if we're talking about miles per hour, that's just a distance miles over a time hour. It's talking about speed. So let's look at one more problem that deals with this idea of proportion and speed. Exercise 3. Erica is driving at a constant rate. So I see that word constant and I think, okay, I'm probably going to be dealing with a line with a proportion. She travels 120 miles in a span of 2 hours. So there's my distance, and this 2 hours is my time. So it's giving me a proportion already. Letter A says, if Erica travels at the same rate, how far will she travel in 3 hours? So I'm going to start off like I always do with my first piece of information, this 120 and 2. So I'm going to put 120 miles over 2 hours. And then I know they give me this 3 hours right here. See how they give me 3? And now here's a tricky part. Am I going to put the 3 on top or the 3 on bottom? Well, what's on top? Miles. What's on bottom? Hours. So I want to match that, so I'm going to put the 3 on the bottom to match. That's the trickiest part about proportions, is knowing where to put your numbers. Always match it up. The top goes on tops and the bottoms go on the bottoms. That leaves the fact that I have this unknown distance that I'm going to label D for distance. And it's in miles. Okay? So now what do? We cross multiply like we've been doing this lesson. So I get 120 times 5 is going to equal 2 times D. And now I simplify and solve. 120 times 5. Oh, wait, where did I get a 5? That should be a 3. I'm sorry. Let me fix that. It's not 120 times 5. It's 120 times 3. My apologies. So I get 120 times 3. That's better. That makes more sense. 120 times 3 is 360. And 2 times D is just 2D. And now I need to get D by itself to figure out her distance. So I divide both sides by 2. And 360 divided by 2 is 180. So what this question is asking, if she's going at the same rate of 120 miles in 2 hours, in 3 hours she will have gone 180 miles. This is how your GPS figures out your estimated time of arrival. A GPS can figure out how fast you're going and then, calculate all these rates and figure out when you'll get to where you're going. It does the math inside the machine. And someone had to know this math to program it. That's what the GPS is doing. So letter B, write a proportional relationship now between the distance she will drive over time that she travels, assuming she continues at this rate. So this problem is very similar. I'm going back here for a second. This problem is almost identical to this problem C right here, where we had the 2 variables and had to solve. But now instead of apples and cost, now we have distance and time. So I'm going to write my original proportion again, 120 miles per 2 hours. And I don't have numbers, I have variables, so I know that D is my distance in miles, so I'm going to put D on the top to match the miles on top. And then they're making me use T for time, so I know that these two things match. And then, just like before, I'm going to cross multiply. Multiply the 120 and the T, and multiply the D and the 2. When I do this, I get 120 times T equals 2 times D. If I keep simplifying, that gives me 120T equals 2D. And remember, I'm trying to solve this for D. So I'm going to divide both sides by 2, so I get that D by itself. And when I do this, I end up getting that D equals 60T as my equation. Okay? Now let's take a look at letter C. What is the value of proportionality constant? What are its units? Now that's a really crazy question. What is this question asking? Well, we need to go back to our original page on our lesson. See how it says y over x equals a constant? Well, a constant is just a number. So if I go back to my original problem of my rate, what is my original rate here? 120 miles per 2 hours. Well, all we have to do is get 120 divided by 2. I have a number on top of another number, and that's going to give me a constant of 60. So I've taken two variables, the miles and the hours, and gotten a constant by dividing them. What are its units? The units are miles per hour. Okay, it's a really tricky, it's actually a very simple question, but it's worded in a very difficult way. Letter D, how much time will it take for Erica to travel 150 miles? So this question is asking us for time, knowing our distance. So what we have to do is use this equation. See this equation, D equals 60t? So I have D equals, actually I'm writing it in purple so you know where I'm getting it from. So I'm getting it, this equation, this right here. I'm drawing arrows at it. Here's the equation. D equals 60t. What should I plug into here? What do I know? I know, hold on, I know the 150 miles. So is miles a measure of distance or a measure of time? Well, miles is a measure of distance. So instead of saying D equals 60t, I'm going to say 150 equals 60t. And now I can solve for the time. Divide both sides by 60 to get t by itself, and I get t equals a decimal, but that's okay, 2.5, and put the units of hours, which means that it's going to take her 2.5 hours to travel 150 miles. Okay. Now letter E is saying graph. Graphing requires us to make a table, and honestly, we have a lot of the points already. For, oops, let me start over here, sorry. We have a lot of the points already that we solved in this, right? And what we can do, you know what, I'm sorry, let me start this over so this makes a little more sense for you. So here's T, and here's D, and our equation is D equals 60t. So I have a time of 0, so I'm going to plug in 0 into here. So 0 times, oh my gosh, this pen. When I have 60 times 0, what do I get? 0. At time 1, 60 times 1 gives me 60. So after 1 hour, I go 60 miles. If I plug in 2, I get 120. So after 2 hours, I go 120. After 3 hours, I already figured that up here. Remember this 3-hour problem up in letter A? How much did I go? 180. Well, that makes sense because when I do 3 times 60, that does give me 180. So I know my equation is right at this point, and the equation is just helping me figure out what points to plot. I'm going to repeat again. I'm taking these t values and plugging them in to find D. And now I can plot these coordinates. So these just turned into coordinates of 0, 0, 160, 2, 120, 3, 180. So now I just have to plot these points over here. So here is 0, 0 always. 160, these are going up by 2's. So 160 is right here. 2, 120 is right here. And then 3, 180 is right here. And notice it formed a straight line because it's a constant rate of change. She's always going 60 miles every hour. It's constant, so it's going to form a line. So what we were talking about earlier, what does this constant of proportionality represent? This 120 divided by 2 gives me 60 here, miles per hour. What does this represent? This represents speed, like we talked about, right? This represents her speed, how much distance you cover per time. Okay? Good luck on your fluency. This is not something you can copy and feel confident with the mastery. It's really not. This is a tough lesson. I know Ms. Vasquez is making notes for you guys to help you in her class. Please attempt the fluency on your own. Remember 6.1 and 6.2 are combined mastery, so don't ask for mastery until 6.2 is finished. Alright? Good luck, guys.